Welcome back with me here at MPB, Ms. Killen. We are still in Unit 6, Introduction to those Quadratics, and now we are looking at special case number 2. This is lesson 5. We are looking at SSE 2 and 3A, and we're looking at REI 4B. I can factor and solve quadratics through using difference of squares. So we are going into those difference of squares. So let's review the special case, the first one that we had, where we had the perfect squares. I noticed that this first one and the second one were perfect squares. So I took my square roots and I got x plus 3. 1 times 3 is 3. 3 plus 3 is 6. So I have my perfect square. So that was our first case. So now, taking that into consideration, let's look at this one. This is our second case. Now, when I have a binomial that's in this form, a squared minus b squared, it's called the difference of squares. So that means it's going to be a subtraction problem. And it looks like this. So if I FOIL it, x squared negative 5x plus 5x minus 25, putting my like terms together, that's what I'm left with, because negative 5 plus 5 is 0, so it's gone. So I'm left with x squared minus 25, difference, subtraction, perfect squares. X squared is perfect square, 25 is a perfect square, so there we go, it's a difference of squares. So let's look at this one. This is not difficult, I promise. So when I factor these, I need to remember that I'm looking for a plus b and a minus b, two different numbers. One of them is going to be a plus sign. One of them is going to be a subtraction sign. So I have this here. So let's go ahead and FOIL it on out. I have 25x squared negative 15x plus 15x minus 9. Like terms together, 25x squared minus 9. Now you're saying, Ms. Killen, I see what you're doing, but I'm just not grasping what you're talking about. Good question. Normally you will see 25x squared minus 9. It's going to ask you to factor it. So what you're doing is you are building two binomials by taking square roots. And we're going to do that in a few lessons in this chapter. But I want to see, and I want you to make a connection to when we get there. So if I wanted to go back and see what I got from taking these perfect squares and going backwards, let's see. So if I took my square root like we did first time, square root of 25 is 5, square root of x squared is x, square root of 9 is going to be either a positive 3 or a negative 3. And I go back exactly from where I came. That's how we're making this connection. Remember in our last lesson I told you that we're using these as building blocks? Here's one of those building blocks. So when we get to taking those square roots, now you can see from this lesson how this lesson is going to help you build to that one. So let's look at some more. Okay, so if you look at number 1, we just left it at 6k plus 8, 6k minus 8. So that one's good. So the dinosaur is also telling us to always look for a GCF. So we may need to look for a GCF before we can factor anything. So let's go ahead and look at this. All right, so I have an 898. We know how to put those in our calculator to see if there is a greatest common factor that we can use. And what do we find? We find it 2. Now, let's look at our variables. I have 3 A's and I have 1 A. How many do they have in common? Exactly right. So I pulled out that greatest common factor. So now I'm going to bring down what's left and see what I've got. So I have 4a squared minus 49. Well, look what's in my parentheses. That is a wonderful example of what? Difference of squares, subtraction, and the perfect squares. So let's see. If I took the square root here and took the square root here, bringing down that bad luggage, and what do I have? building those two binomials, Miss Killen, is what we got. So I've got 2a here. I've got 2a here. I'm going to have a plus. I'm going to have a minus. Take the square root of that 49, and I have 7. So I've seen us go from smallest to get the difference of squares, and then I've used the difference of squares to go back to the binomials. So I've got those two building blocks that's one on top of the other, showing us how that they're connecting. So let's look. Time for us to master. All right, so what I want us to do is I want to solve the equations. I want us to look and see what we've got, work what we've seen to do, and then see if there's anything else that we have to do to find those different difference of squares, or have to do the factoring out our GCF, or maybe finding roots or whatever. So I want us to take a minute, work these problems, pause the video, and then let's come back and see what we've got. All right, let's see what we've got. Let's see what we can do. I want your math to be in front of you and watch what I do. Look at my math, look at your math, and let's see if they go together. Here we go. So the first thing I have 0 equals 121 n squared minus 100. So I notice that the 121 and the 100 are perfect squares, so I'm going to take the square root. Let's get us a different color, Miss Killen, because I can't see red on red. So I'm going to build those two binomials. I have 11 and 11. Square root of n squared is n. With these perfect squares, I have a plus and a minus. Square root of 100 is 10. Now, this one has where it equals 0. So that means it's looking for those answers, looking for those roots, looking for those solutions. So what I'm going to do is I'm going to make both of these binomials equal 0 and solve for my variable. So let's see. So I am making them both equal 0. I am subtracting 10, doing my opposite operation. So I have negative 10 equals 11n, division. So n equals a negative 10 over 11. Let's go to the next side. I'm going to add my 10 to both sides. So I have 11n equals 10. Divide. Divide by 11. Let's divide by 11. So my n over here is a positive. So for me to put my answers would be a negative 10 over 11, comma, positive 10 over 11. Now, you may be saying, Ms. Killen, why did you keep on going? In the last one we didn't. Why did you keep on going? Because this one said equals to 0. With that one little part, it tells me, it wants me to keep going and get those variables by itself. So that's how it's very important to make sure that we're reading these problems, because the problems itself can give us all the information we need. Let's look at the next one. It says, consider this. So now, 7's not a perfect square. 63 is not a perfect square. So really all I'm looking at right now is just taking a GCF out. So let's go ahead and take this GCF out. Now, you can put it in calculator, try it in Desmos, and for me to get my greatest common factor of 7 and 63, what do I find? Exactly right. I can pull out a 7. Now let's look at my variables. I have 3 and I have 1. How many do they have in common? Absolutely. And then I'm going to bring down what I have left. Whoa, Miss Killen. You mean I took out a greatest common factor and then I ended up with a difference of squares? Yes, we did. So now, since it's a difference of squares in the parentheses, I'm going to factor that difference of squares now. So let's look. Bringing that bad luggage down and building those two binomials. So I've taken the square root of everything. Square root of x squared is x. I'm going to have a plus and a minus. Square root of 9 is 3. And this is my final answer. But, Ms. Killen, why didn't you do everything you did on the red circle to the brown circle? Good question. My red circle equal to 0, so it wanted me to go further. My brown circle just wanted me to consider the expression and reduce it by factoring. So that's all I was doing. So when I say make sure that you're paying attention to the questions, get all the knowledge and all the information you can out of these questions, this is a very good example of showing us the questions can help guide you to an answer they want. Good job. Those are good questions. Factoring special cases, we need to remember we've got our difference of squares, we've got our perfect squares, depending on what our question asks us, depending on what we're going to do with those difference of squares or perfect squares. So these are the two special cases that we have to remember. Thank you for coming to learn here with us at MPB. I'm so glad that you came to work with us and learn with us. I am Ms. Killen. Have a great day.